Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We yesterday did a chat, actually, so I didn't get to the thing that I wanted to get to. We do have one bit of cleanup to do from a previous stream. I might hold that off for a little bit just so I can start on something today that I kind of want to start on. And that is, I wanted to talk a little bit about sort of finalizing, or at least putting into its final API form, the arenas, memory arena stuff that we have been using on the stream for all of Handmade Hero. And what I wanted to do there was I wanted to sort of show a little bit more about how the arenas could be made to be more flexible during development if we want them to be. And I kind of just wanted to give you a little bit of an outline on how that would go. So I'm just going to do that, and I'm going to talk about that a little bit now. Oops. So if you remember back when we first started doing dynamically allocated memory, which is what we have used for most of the things in Handmade Hero are allocated at runtime. What we were doing is we're essentially saying, all right, let's go ahead and take a giant block of memory, right? And so this giant block of memory would be as much memory as the game was going to take, let's say. So maybe it's going to be 4 gigabytes of memory if this was like a big AAA game or something like that, right? And we had I don't know if we have it set that way right now, but at one time we did set it to 4 gigs or whatever. It might not be set to that anymore, but you get the idea. So what we would do is we would then say, like, okay, we're going to partition this up, and we'll partition this up into like 1 gigabyte will be for like the world or something, and 2 gigabytes of that will be from for assets or something, and 1 will be for scratch space. I don't know. I mean, right? We'll just partition it up. And then we would sub-allocate out of these when we need things. And obviously, there's a nice benefit to doing it this way. It obviously keeps everything nice and simple. But it does have one obvious drawback of doing this, which is that while it works fine if we know that we just want to constrain the game a priori to 4 gigabytes of memory, which we may want to do in the final shipping version, it does make an obvious sort of limitation to the game if we wanted to say just let the game use as much memory as the game wants to use, right? And this may not be super important to something like Handmade Hero, because on Handmade Hero it's probably true that we will have a good idea of what the memory bounds for the game are when we ship it, so that we could just say here's how much memory it tends to allocate and we're done. But you could imagine a situation where you didn't want that to be true. So an example would be, let's suppose that we were to ship a world editor with Handmade Hero sometime, and now the user wants to be able to make levels in these things, and because they're crazy or whatever, and you know how people are when they mod games, we don't want to constrain them to only making worlds that are a certain size that fit into our pre-allocated footprint. We would rather let the user make worlds as big as they want, so long as they have enough RAM for it or something, right? And obviously, right, we could even come up with approaches to that problem that are different. We could start allowing you to do things out of core, which we have a pretty easy way of doing in our system now, actually, because we do have that sort of world storage that packs entities and then unpacks entities and all that sort of stuff. So we could actually switch to out of core, and maybe sometime in Handmade Hero we'll actually do that just to show how you would do that, because it's pretty easy given our current architecture. But that's neither here nor there. Even in that situation, you may want to empower the users to use as much memory as they have, because hey, they paid for it, and if they paid for 64 gigabytes of memory in their sweet gaming rig and they want to use it, you should let them, right? I mean, if we can just say like, hey, like, dedicate more of that to the game, then great, right? And so there is a certain amount of value here to being able to say, maybe we can let arenas grow to whatever size the user wants them to grow to, and just let them kind of roll the dice, right? if they want to max out their system and crash the game because they allocate too much memory that the system can't handle or something, oh well. And we could even be sensible about our allocations if we want to, and try to do things that will make sure that we can issue an error message in that case cleanly, so the game doesn't crash. It just says, hey, you're trying to make a world that's bigger than what you could fit in your machine or something. So we have a lot of options there, but point being, it would be nice to be able to do that. Similarly, another thing that would be nice is during development, we don't really know a whole lot about our memory profile during development because we're making decisions here and there. We're changing the way things work. We have things like the debug arena that's not even part of the shipping game. So why we would ever care about pre-allocating that, it doesn't make any sense for us to even really think about how big that should be because it's purely a debug thing. We just want it to expand to hold as much debug collation data as we need it to. We don't want to have to pre-partition it, right? And so again, even if we assumed that we were going to ship the game with a fixed allocation block and not allow any of its arenas to grow dynamically, that doesn't mean that we don't still want that expanding arenas bar, because it can simplify our development process by allowing our arenas which do not have to be shipped at runtime to grow dynamically, like in the debug case, and even the arenas that we do want to make sure are fixed allocation sizes, because that's maybe something we want to guarantee about our runtime, even those also don't have to be set to be fixed sizes during development. So that way, during development, we don't have to think about it. But then as we get towards the end of development, then we can start to look at how much memory are we using and then convert to fixed at that point, right? So expanding arenas, useful thing, and they kind of extend the arena concept very naturally in a way that allows you to make them grow to take up as much space as they need. So let's talk about what's happening right now with our arenas and how we might implement this. It's actually very, very simple. So if you look at how our arenas work right now, there's a certain amount of memory. There's a base pointer, right? And a size. And then you can imagine at the end, there's essentially sort of an ending pointer, right? It's like that's the end of this arena. And so what happens when we allocate, right, you remember, we've got this pointer at the base. We initialize a pointer that's pointing there, which is where we're at. And every time you ask for an allocation, we just move that pointer down, right? So we essentially say, okay, if we're going to write something in that's, 64 bytes, we write in that 64 bytes, or we don't really write it in. We just return the pointer that we're currently at, and then we move 64 bytes down so that the next thing just gets stacked on top of it, right? And then we do a little bit of work there where we try to do alignment as well. So we allow you, when you allocate, we may push the allocation around a little bit. But otherwise, it's exactly, it's all analogous, right? So if we wanted to, what we could do is say, well, we already have an assertion in there, if you go look at the code, where if the at pointer is all the way down here, and you tell us to allocate something that's too large, so the new at pointer would overflow the bounds of the arena, we already have an assert in there to tell us we blew our memory budget, right? So what we could do instead of that assertion, if we wanted to, is we could just say, oh, well, when we would have thrown that assertion up and said, hey, halt the program, tell the programmer you messed up, what we could do instead is go ahead and allocate a new block and just put the at pointer there and then keep going, right? And just do that as many times as we want to, right? We could keep allocating new space for our arena as we go. And so we can just fill it all the way up, up until we run out of memory in the machine to allocate. It can just keep growing and growing and growing, right? And mind you, since this is allocating pieces at a time, those pieces are still guaranteed to be contiguous, because if I couldn't have fit the piece, I put the whole piece on the next one. What that means is we don't have to worry about copying things from this arena when it expands. A similar technique like the dynamic array, right? Dynamic arrays are the kind of things where, okay, I've got, a few elements here, 0, 1, 2, 3, 4, 5, whatever. And then I want to insert a sixth element, but I can't because I don't have enough room to insert the sixth element. There are only, I should say the seventh element. There's 6 elements here. I have 6 elements in here. I want to insert the 7th. I can't do it. because there's only 6 elements in the array, there's no space. So then what they do is they say, well, okay, it's fine. Just reallocate a buffer, and if you can reallocate in place, great. If you can't reallocate in place, just copy it down the old values, and then you'll have room. And so that copy has to happen anytime you couldn't have gone back and asked the memory allocator if there was space here that the memory allocator hadn't used that happened to be adjacent. It can just bump it out. But otherwise, you got to do that copy. This doesn't have to do the copy because no one is addressing into this thing, right? If they're addressing into something, they're addressing into a sub portion of it that was allocated with a single call, and we know that that will still be contiguous because we're never breaking up those allocations across boundaries, right? So if we would like, again, it's very easy for us to go ahead and make our arenas support this natural expansion process. And so I thought, even though I don't really know that we need it too terribly badly, I felt like since people kind of didn't have when I talk about the arenas, people are like, oh, that's really interesting, because a lot of people are just only taught dynamic allocation. They're not necessarily taught some of these other nice techniques. Arena allocation is a very common technique in production programming. It's just, it's kind of one of those things that isn't taught as often anymore, again, because of this kind of weird move to not knowing what memory is doing and stuff like that, right? But old school programming arenas is very, very common, very, very straightforward thing. And so since a lot of people hadn't really seen those, and I think should absolutely see them, I just wanted to take a day or two and show you how to make the expandable kind, because it's very, very simple. And then you can use it in all sorts of other areas where you might want to use arenas, but maybe were afraid to because you didn't want to have to pre-guess how much memory you were going to take. For example, in an application or something like this, right? So what I would say here is the first thing we're going to need, and I think we already kind of started this a little bit, we just never really did anything with it, is we're going to need a way to get more memory when we need it. And so we have our platform APIs in here, right? Where is that guy at? Here it is. We have our platform APIs, and we need to be able to allocate and deallocate memory. So you can see those calls are here. I don't know if we actually ever used them. I can't remember. Yeah, we don't even use those calls, but we did throw them in there. So I think we already have set ourselves up to do what we need to do, which is be able to get more memory when the time comes, right? So this should be very easy for us to do. Now, it'll probably only take me a little bit to add the expandable concept to our arenas, but we will still have another problem, I suspect, that is going to be a little bit trickier to solve on the platform side, and that is just the looped live code editing. Once we allow our arenas to dynamically allocate, we have a little more work that we're going to have to do on the looped live code editing side of things, but we will also get a really big dividend when we do that. I don't want to spoil what it is yet. Those of you with sharp, handmade, brainy brains probably already know what it is that we're going to get. But for those of you still in suspense, let's go ahead and get started here so we can get to the payoff. That'll probably be tomorrow, though, because I spent some time talking about it, so I don't know if we'll get it all in today. So here is our memory arena, and you can see here we've got a size, a base, and a used. And so it's just kind of going up there. I don't know. I don't necessarily know that that's the most efficient way to store it as opposed to doing a point or whatever, but this is basically the same thing, right? We're just saying, here's how big it is total, here's our amount used, so anytime we know where that at pointer is, right, this at pointer here we know is this far up from base, and this is the maximum we can go, right? So if we come in here and we say, well, we want to push some memory on here, and oh, this is interesting. Yeah, we want to push some memory on here, and as far as I can recall, all of our allocation then goes through this push size call. So if we just modify this one, we should be good to go. What it does is it says, all right, figure out how much we actually need to push on there based on the alignment. You can see it happening here, and then you can see the assertion, which is going to say Oh, wait, that's not the assertion I'm looking for, though. This is the assertion. The assertion, which is going to say, hey, if where we're at plus how much we need to allocate is going to blow out the size, then we're just going to stop. We're going to halt right there. Oops. As I pull the thing out of the slot, I should probably check to make sure that I haven't disconnected the audio. Okay, yeah, no, I'm still going, so that's good. So really this is the if that we're talking about here. This is the if that we actually need, this is the condition that we actually need to satisfy. So what we could do here is we could say, well, all right, what we want to do is say if, instead of making that an assertion, if we were going to exceed the size, right? What if we could just do something here that would allow us to expand the arena and not have this problem where we're gonna where we're gonna run out of size, right? So hopefully you can kind of see where we're going with this. It looks like Handmade Memory has nothing in it, apparently. All right, everything's in the H file. So the memory arena here, right, it has this base pointer. What we need to do is, if we're going to blow the size, what we need to do is basically allocate another chunk of memory to replace the base pointer with a new base pointer that we can use. Now, the problem here is we don't actually know how much memory we should allocate, because we could just allocate however much we just need right now, but that's not very efficient, because then the very next time someone calls us to allocate something, we're going to have to do it again, right? Meaning, if this person is asking us to allocate, 64 bytes of memory, and we find that we're at the end, so 64 bytes won't fit, we certainly don't want to allocate just a 64-byte chunk from the operating system to stuff this thing into. That'd be horribly inefficient, and we would have to do the same thing again next call. So what we want to do instead is think, okay, if it's a really large allocation, right? If the person asked for 16 megabytes of data here, then it maybe makes sense to just allocate the 16 megabytes and give it back to them, no questions asked, right? But if they're only allocating a small size, 4K or something like this, then we probably want to have some minimum allocation size that we always allocate, because we know we're going to get more allocation calls in the future. We want to minimize the amount of times we have to go through the operating system, right? Because if we start going through the operating system too often, we lose most of the benefits of the arena in terms of efficiency. We don't lose the benefits in terms of cleanup, because cleanup is still nice and easy, much easier than it is with sort of spaghetti string smart pointer nonsense, right? But we don't get the efficiency anymore. We're back to being inefficient like a regular allocator is once we give that up, right? So what we'd rather do here is have some minimum size. So what we want to do is say, okay, we've got a memory that says this is going to be our block size, right? Like how much we're going to allocate. We know that we want it to be at least as big as the size that we're trying to allocate, but we also want to know more specifically that we're going to allocate at least as much as our minimum block size. Like so, right? Another way to write this, I don't know if we have a min-max macro. I think we did, and I think we make them as a macro. I don't really remember. Let's find out. Yes, good. So another way to write this would just be to say, I want it to be whatever the larger of the two of these is, right? I want, if the size requested is bigger, then we'll use that. If the minimum block size is bigger, then we will use that, right? So at that point, we know what we want to do. We want to now allocate, that memory from the system. So we want to go back to our platform code here, and we want to use the allocate memory call, right? So we want to say allocate memory. Now we need to get this from somewhere, and of course, in Handmade, I believe we have that. It's this platform API thing here, right? So we can say, hey, platform allocate memory. The memory we're going to allocate is whatever the block size is. And I don't know that we pass anything else. Oops. I don't know that we pass anything else in there. I think platform allocate memory probably takes size. Yeah, it does. And that's going to give us back a void star. Right? So that new void star would just be our base pointer now, right? So if you take a look back at the memory arena here, we now have, if we were going to overwrite this memory arena's data, we would have something like this. We'd say, okay, there's an arena size pointer, and we know that that's going to be our block size. I'm not pointer, value. We have a base pointer. The base pointer is going to be the allocation. We have used, which is how much we used, and that's going to be 0. And then we have temp count, and temp count would remain the same, because if we're inside a temporary memory block, we're not going to no longer be in one just because we moved to a new block. We're still inside a temporary memory situation, right? So now, once we're done with that, we should get to the point where we can assert, right, that we have the space that we need. We should be able to say that this, at this point, should always be smaller than the arena size, right? So there you go. And hopefully what you can see here is we're not quite done yet. We have some more stuff to do. But you can kind of see, all right, so what we do is we say, every time we're going to overflow, we just allocate a new block, and we just pretend that we were back at the beginning. And so the allocations can just proceed as normal. Now, get effective size for is a problem for us in this regard. It's not a problem for us practically speaking, but it is sort of a problem if we wanted to really be sort of judicious about our code here. Because if you look at what's going on, when we say get effective size for to figure out how big of a thing we're actually going to have to allocate, what you'll see when you come up to this call is that this is going to be based on the alignment offset. And when we ask for the alignment offset, you can see that it matters what the used value was. So it matters essentially, it matters where you were in the arena as to what the alignment criteria, how much we're going to have to move to fulfill the alignment criteria, right? Because if we're on the 3rd byte of the arena, then obviously if you want 4-byte alignment, we're going to have to move 1 byte forward before we do the allocation, meaning the effective size is the size plus 1. If we're right on the 0 byte, then it's just going to be the size, because we don't need to move anywhere to ensure our alignment. And so get effective size for is actually going to return a size that is not actually the size we will need in the new allocation, right? The new allocation we could assume is always aligned. The reason we could assume that it's always aligned is because if we're going to be allocating from the operating system, we can assume that the operating system's block allocations that come back should always be aligned to the maximum alignment, right? But even if we didn't want to do that, we could pass the alignment here to the operating system to let it know we want aligned memory. But again, operating system memory is always going to be aligned in Windows to 64K boundaries. So at that point, there's no reason we're ever going to do that. So if we wanted to, we could actually change this to being, instead of size, it could be size init, right? Because at that point, we kind of know that we don't have that problem anymore. So really what we would want to say is size, equals size init here, and say, note Casey, the base will automatically be aligned now. And so on. Now, what's interesting is it looks like we didn't assert our alignment after we do the alignment, which is a little weird, but either way, whatever. I should probably add one of those in here. Meaning there should be a thing which says, hey, try to actually ascertain that when I did the alignment, it was actually aligned, right? Yeah, but anyway. So that's pretty much what we're looking at. Now you can see that we have a problem here, which is that this minimum block size we don't have. Like, we don't know what the minimum block size is. But fortunately, that's not a particularly onerous problem for us, because chances are we can put that on the arena itself. Meaning, when the person created this arena, probably they had an opinion about what that minimum block size would be. And even if they didn't, we can by default make that minimum block size be something reasonable. Now, when we actually initialize arenas, I think we don't use clear to 0 at the moment. Let's see. Yeah, because the size value here is getting set, the size and the base are getting set like so, right? So we call this initialize arena. We could very easily just say, okay, the minimum block size in here, when we do minimum block size, is just going to be whatever. It's going to be 64K or something. So the minimum size we're going to allocate when we allocate is going to be that, and off we go or whatever, something like that. Maybe that's too small. Maybe it should be a megabyte per. I don't know. You're free to do it. Maybe a gigabyte's better. I don't know. Probably not a gigabyte. So I don't know. We could do to-do Casey tune default block size eventually. But really what we would want to do here is say, okay, chances are when people initialize these things, they would also want to be able to specify that minimum block size themselves. So for example, we could do something like this. Inline void initialize arena, where we give it the memory arena, and then we say the minimum block size. And that would be kind of an interesting thing as well. And what you would see there happen is we would take all of this stuff, we would take all of this stuff and actually just initialize it to 0. And then inside here, we would set that minimum block size. Now you may be asking, well, what's going on here? You're not giving it any memory to start with. And the answer is, well, once we have expandable arenas, we can choose not to bother initializing them with any memory, right? We can just set a minimum block size and then just know the first time someone actually does an allocation of this arena, it will go allocate something of the minimum block size, right? So we don't need to pass in a base pointer anymore if we don't need to. We can just initialize an arena to 0 essentially, and then just set the minimum block size, right? Now, I would go one further and say, let's support 0 as initialization here. I'm a big fan of 0 as initialization. It's one of my favorite things. I think it reduces bugs a lot, and it also increases efficiency in a lot of ways, potentially, depending on the circumstances. So the other thing I would say is, let's have a clear to 0 ability on this arena by saying, OK, the minimum block size could be set to 0. And we have a default block size thing here. So essentially what we could say is, hey, if you don't set a minimum block size, because we know a minimum block size of 0 can't be valid, because that would not allow you to actually allocate memory at all. So what we could do there is say, all right, if the minimum block size isn't 0, then we will use it. If it is 0, we'll set it to the default, right? So when we push through here, we'll just say if arena minimum block size is not set to anything, then we will just set a minimum block size equal to whatever our default block size is, right? And so now you can see a really interesting thing that we've done here. This is something I'm always pretty excited about when I can do it. We've got a relatively complex thing that even has a pointer in it and whatever. We were still able to make initialization 0 is initialization work, right? I feel like that should be a term. Like, you know how people have RI, like resource acquisition is initialization, RAII? I hate that pattern. I think it's a really bad pattern. How about 0 is initialization, ZII? ZII, like, RAII equals bad, ZII equals good, right? That's all you need to know. There you go. Programming. Done. So yeah, 0 is initialization is really nice if you can do it. It means you can just take memory, block clear it to 0, and know that it's ready to go. You don't need to have constructors. You don't need to worry about pointers pointing to things. It's really nice. So if you can make it happen, it's always kind of nice. In this case, we now have a really good way to make it happen. And that is to use the sort of the trick of checking the minimum block size. Now, what you'll notice is I kind of hid that in there in kind of a nice way. We already have to do this if check to see whether or not we've hit the boundary of the memory. Well, that's not going to happen very often, right? The whole point is if we're trying to be efficient, we're not going to hit that very often. So what I did is I buried this if inside there, so it's nice. We don't have to worry. It's not like this cost us very much to do, because adding that extra check it's already pretty much free because it's only inside this fairly rarely taken branch. So the work we do in here is just not relevant, right? This is called so infrequently, hopefully, if we've tuned our parameters properly, that we don't have to worry very much about what we do in here. So it's pretty much free too to add that check, I believe, because I don't think we'll pay any cost for that. So it wasn't like the checking every time is somehow less efficient. All right, so that is a growing arena. We need to actually add this in now. Let's see here. And is it just max? Oh, that's in handmade.h, is it? All right, fine. Now it isn't. So yeah, I'm gonna move over here so my head's not in the way. All right, so now we've got pretty much everything we need. The platform bit inside memory here, we do have the problem of these arenas, I think, get used in places where platform, I don't really know if platform always exists, is one problem. So, you know, something that kind of would have been nice, and I'm not sure exactly how we would want to tackle it, but one thing that would be nice is if we had a way of always getting that platform variable somehow from somebody, regardless of, or, you know, having a way of getting that call, regardless of where you were. And so, you know, if you're in the DLL, we want this to be visible to you, right? And we sort of can do that. Global variable here, I don't know if that's actually being used to make this thing static or not, because I don't remember what, again, we set at this point our definitions to there. But global variable, yeah, static. So what we could do there if we wanted to, right, is we could make that an externally linkable variable if we wanted to. And we could make it so that that way the, you know, we could forward declare it in various places or other things like that and make sure that it actually works. Now, the way that that happens is, I believe it's inside game update and render. You can see here where we basically copy the platform API from the memory that we're from the memory block structure, the thing that comes in from the platform layer. And so when we do that copy, right, that's initializing our version of the global variable. And in the platform code, which is still using the arenas as well, right? In the platform code, we have that same data here, right? We filled it out in game memory. So we could easily make it so that this thing was accessible in some way by the shared, you know, by the code that's in the platform layer as well. We just need a good way of actually doing that, right? And so one way that we could do that is in the platform thing here where we say in handmade.h, where we say platform, like I say, we could try making this an extern, right? And then if we make it an extern, we can actually put it up into, we can put that up into the platform code and say, hey, yeah, no matter where you are, there will be one of these that you can access, but you're going to have to get it from different places depending on the circumstances, right? So we could say right here that you're going to be able to get one, right? There we go. That you're going to be able to get one, right? And so then what we need to do is we need to figure out where we can define that thing so that it's accessible. Oh, hey, look, we're already actually doing that, apparently, right? So yeah, so we just need one of those in both places, right? So in handmade.cpp, we needed one, and we can put that right here. and then in the Win32 layer, we needed one. And so now we have two different platform layers, and each of them can be used separately. Now, the problem here with platform is I don't know that we ever actually set it. I know it's there, but do we use it anywhere? We do. So there's our update. So then we're all good, I think. Right? Yeah. Virtual alloc, blah, blah, blah. So I think that's it. I think that's really all there is to it, to getting that platform into the right place. Now, mind you, at this point, we have still not really done the actual hard parts of this. We did the easy parts, but we have a few hard parts left to go. We've got about 15 minutes left. If we run it now, nothing's going to happen any differently, obviously. And the reason that nothing's going to happen any differently is because if you, since we're allocating our memory up front anyway, none of our arenas will ever hit that condition. They would have asserted before, right? If they had hit the end of them, we would have been seeing assertions. Since we weren't seeing assertions, we know we're never going to hit the allocation case. So right now, our arenas are actually running exactly the same way that they used to be running. But what we can do to prevent that from happening and force them to go through a different path, right, is we could go in and say, all right, let's take the debug storage size thing, and let's make the debug storage size not actually... let's not have there be a debug storage size. Let's remove that entirely, and we'll just use a growing arena for our debug size, right? So let's say we just get rid of this. We go into our game memory code, and we just say no, right? It's not happening, right? And so now what we could say is, well, whenever this stuff is actually accessing this debug storage, right? Although now that I think about it, I don't know if we need to have this accessible at both places. So this may be a poor choice because we'll have to put the arena out there. Although now that I think about it, I suppose there's no real reason why the arena can't just be out there. I mean... seems like that would just work. Push that on the stack for a second. So yeah, you can kind of see us doing this thing here where we're like initializing these arenas and blah, 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 right? And when we do this arena initialization stuff, right, this is all forcing us to kind of think about things that we maybe didn't want to think about and, you know, subdividing up this memory, but we don't care about that, right? We don't care about how much memory these things are using. It's just for debugging. So this stuff is all just stupid. It doesn't actually help us at all, and it just makes it harder for us to program because it's wasting our time thinking about how big we need to make these things. Now, it didn't waste very much time, that's true, but why waste any time if you don't have to, since we can get all the same benefits from the arena that we were getting before. We don't have to give anything up. And now we wouldn't have to say how big the things were going to be, right? So what we could do instead is just say, all right, the per frame arena. In fact, maybe this is the best way to do it to start with. Well, OK, we'll do it this way. So the per frame arena inside our debug state, we're just going to make the per frame arena be, you know, a dynamically growing arena, right? I guess we should have another arena in here now that I think about it, though. The debug arena itself, when does that actually get created? That's the one I probably actually want to do there as well. Hello? It's this one. So yeah, so that just takes the total memory size of the entire debug system, right? The per frame arena just takes half of that, it looks like. You know, whatever half of that actually is. So if I wanted to start out, what I could say is like, all right, debug state, debug arena, and debug state per oops. They're both getting initialized at the outset here during debug start. And so what I want to do is I want to initialize these arenas with a certain minimum frame size. I guess I don't really care what that minimum frame size is. So, you know, if I wanted to, I could just do it like this, right? I could just say initialize them to 0, and that's all we needed to do, right, if I want to. And again, I'm going to need some way here to tell whether, you know, things are initialized or not, but that would be the only thing that I would actually have to do, right? So yeah, I could go ahead and do that. Do this initialization bit. And then I don't need the total memory size or any of this stuff. This stuff can all go away entirely. And now I just end up having like, OK, there's, you know, there's some things that get automatically allocated for us, right? This also means that we wouldn't have to ever throw anything away that we didn't want to throw away. So it also means we don't have to do the sort of borrowing thing. We could just record as much debug information as we want. And so we could also, you know, create extremely large runs of stored debug information if we wanted to and just let the arenas allocate. So we could do that if we wanted to. I'm actually going to call init arena here. Is it just initialize? And say that I'm going to pass a, well, you know what? No, I'm going to stick to my guns. There we go. So those arenas are going to get initialized to 0, which means they'll just use the default block size. And so all we have to do now is clean up sort of the basic init pass. Requires L value. Do I not pass a pointer to the struct? Is it this? Apparently it is. So yeah, I think that's all we really have to do. When we call debug frame end, you know, we're grabbing the debug state out of this debug storage thing here. And that's just, you know, in the game memory, that's just where we have to store that particular piece of information. And whether or not we get it you know, if we get it or not depends, makes the decision as to whether or not we actually do the debug work. So the question here is, how do we get this thing started, right? Because before we would just pass a block of memory in and say, here's the block of memory. Now we actually have to do something where, okay, you know, if there was no arenas or whatever, those things have to be initialized before we go. And so what we need is some way, right, of recording the fact that these things, you know, in the game memory, recording the fact that these things were not set up yet, right? And so in order to do that, what I would need to do is have something in here that we can use for our initial, you know, for like our base pointer, right? So I would need to have something like this, right, that allows us to go, if that pointer is valid, then we know that we've initialized. If it's not valid, then, or rather, if it's, you know, we could have it and clear it to 0, let's say, right? Then we know that things have gone kind of pear-shaped on us, right? So let's take a look at what would happen if we did it this way. So if I did it this way, you know, and we assumed it was cleared to 0, presumably all the rest of this stuff just works. The only difference is when we go to get this thing out, we would just look at that pointer, whatever that pointer was, instead of actually taking a memory block and casting it. So now we would say, like, all right, when we do debug get state, again, it just looks at it that way. And that's really all that we would be doing. Similarly, we don't have to account for the debug storage size in here anymore. The debug storage size could be removed. And then the debug storage itself also can be removed. Right? So now we've sort of started to do this correctly. Of course, we also have the problem now where we want to set, when we do the game memory, we want to, in here, set game memory. Well, I guess it's probably cleared to 0 for us, huh? Let me just double check that it is. Yeah. So debug state by default would be set to 0. So what we want to do here is we would want to, well, honestly, we probably want to do something a little bit weird. We could, if we wanted to, create the debug struct like here, right? We could just create a debug struct, one of those structs stack, but it would, and point to it, and then it would just be all 0, so you knew it wasn't initialized. But a more interesting might be to just set that debug state pointer to not be anything at all. And if we set that debug struct pointer to not be anything at all, then I feel like we're in a more interesting situation. Because if we set it to be nothing at all, instead of looking at initialized, right, what we could do is just return memory debug state. And initialize would just be whether or not that was set to 0 or not, right? So namely, when we call debug start here, right, and do the if not initialized, and let me take a quick look just to make sure oops, that's the wrong thing. So that's the only place it's called, right, is right down here. So what I might do is say, let's make debug init. We'll pull this out. And then what we'll say is, OK, we're going to return a pointer here. So if you need to initialize the debug system, you can just go right ahead and do it, right? And we're going to need some things that would have been passed through here, right? We're going to need some stuff. So when the debug start situation happens, I guess I also don't know, does assets need to be here? Yeah, it does. We'll have to pass probably something here. Well, maybe not. I don't even know. Do we have to pass anything here? Do we use anything here? Let's find out. Compiler, tell me. Oops. So we do need to know the width and the height that we start out at, because it looks like it's placing an initial thing at that location. So that we can kind of go through here and say, like, OK, we got to pass that in. But otherwise, that's it. So what we can do here is say, like, OK, when we come down here, we can say, take a look. If memory debug state is not valid, we can set memory debug state to be debug init. And if I switch myself over here, I should be able to see, where are we getting that width and height from? Stop blocking my view, please. All right. So yeah. Oops. I passed the wrong things. Isn't that always the way? There we go. So yeah, so once we have this done, where we're going to say, like, OK, if we need to initialize it, we'll initialize it in here. And we don't need the if anymore, obviously, because we're going to actually create one of these ourselves. When we go to initialize the debug code, what we need to do now is have some way of getting that initial memory for the debug code. Now, it was a bit of a catch-22 situation, right? What we want to do is initialize these arenas here. We would probably want to allocate it out of the debug arena, but we don't have a debug arena yet. So what do? Well, it's kind of funny if you think about it. One of those debug arenas is really not, there's nothing magical about it. It's just a struct, right? All it is this struct. So if we wanted to, we could do this. We could say, here's a memory arena, right? And what I want to do is I want to take my memory arena and like do a bootstrap on it, right? So it's set to 0. There's nothing in it right now. It's initialized. Then what I want to do is I want to get my debug state from the bootstrap arena. Right? So now I have allocated some memory, because the memory arena will allocate a block of memory. It'll give me back my debug state, right? Then what I'm going to do is just say, hey, guess what, guys? That debug state, you know, that's actually going to hold the arena. So we just block copy the values in here into our debug state, right? And that's it. Does that make sense? I know it's a little tricky, but it's very, very simple at its most basic, right? Oops, I got to tell it what we're actually allocating. There you go, right? And so now, hopefully we can, I probably got some bugs in here, so we're going to have to do some stuff. But hopefully we can go in and actually see sort of that one piece of it work. Let's go ahead and switch to debug. Go. And here we are. Okay. So we look at memory debug state, it's not set right. So we go in here, we create one of these bootstrap arenas, right? And the bootstrap arena, as you can see, has nothing in it at all. So then we say, hey, I need a debug state structure, please. So we come in here and we say, all right, well, give us one of those. How big does it need to be? That's how big it is. It's pretty big. It's pretty beefy. We take a look at what the minimum block size is, and we find that the minimum block size hasn't been set. So then we set it to 1 megabyte, right? Then we say, okay, we wanted that much memory. Here's the minimum size. The minimum size is bigger, so we end up with a block size that's the minimum block size. We try to allocate it. We call into the platform layer. It calls virtual alloc with that size. Now we've got a pointer to that much, and that's how much the size is used, right? It's all good. We then do the alignment. We zero out the block of memory that we allocated, and now we're good to go. And now we have our debug state, right? But our debug state has a debug arena that shows that it has nothing in it, which is not correct. We want to use that part that we just started with. So we copy the memory in, and now that debug arena is actually the bootstrap arena. And from now on, everything else goes just fine. Now, at this point, what I'm realizing is all of this stuff that's initialized to 0 is a complete waste of everyone's time, because I was initializing the whole debug state to 0 because I kind of wanted that to be a 0 initialized thing. So I have no idea why any of this stuff is set to anything other than things that are non-zero, right? So really, that's all that we would set. This does not have to be set. None of this stuff has to really be set. I also don't know why any of this stuff is even here, because I don't even know what it is. I guess that was just some test code that's still in there for no reason whatsoever. Similarly, we don't need to set things to false because false is the default. And so there we go. So that's actually our new startup code, right? Okay. So sorry, back to the walkthrough. So here we are, right? So now we've got our debug state, and it has its own arena like we wanted, and the arena is getting used. We return it back, and now we have inside our memory pointer, right, we have the debug state should actually be set. There it is. And it's got, of course, the arena that we saved right in here. And we also are set to initialize, although initialize isn't actually needed anymore. So what I would like to do is just get rid of it before we forget, because I don't want people to think that that's doing something when it's not doing anything, right? Okay. So let's, oops, that's not what I wanted. I wanted to step through that. Let's try that one more time. Okay. So then after debug state is set, we now have everything doing its thing like we expect. And it looks like we get hung up in here somewhere. I'm not really sure where, so let's take a look. It's probably just a bug that I have inadvertently introduced. Doing who knows what. What is our hash index? Okay. While not result. Aha. So this is actually this was our code to make sure we only used a certain amount of space for the debug arena stuff. And we don't really need that anymore, right? So this is just going to loop forever because it's like, well, I don't have any room. I have 0 room, so there's no way I can ever store any debug events. So we really don't really need that anymore. It's super not necessary. But I don't know. That doesn't necessarily mean we want to do it that way, right? We could still say that we want the per frame arena to be capped at some level, right? I mean, I don't know. We could just say that we don't want to take arbitrary amounts of room. But if we did want to take arbitrary amounts of room, I just want to make sure, like, let's say that we just always did this push struct here, right? And didn't do the freeing. I'm wondering if free oldest frame, does free oldest frame get called in the course of business? So it does. So these will get cleaned up naturally. So what I'm thinking here is what we could do is just say, no, let's not do that anymore. Instead of like reclamating here and doing the first free stored event thing, right? What we could do instead is say, like, all right, take this code and just assume that you never free. If you want memory, you can just have it, right? Oops. And then off you go. So yeah, now that arena is just a dynamically growing arena, right? So you notice we've taken something that previously forced us to specify how much memory to take and replace it with something that we don't have to specify how much memory to take. And it just kind of will grow as necessary, and all the rest of the code runs exactly the same. And you can see here that we're still stable. We're not doing any allocations or deallocations per frame, right? We're totally stable because it's only going to grow to the size it needs, and then it's going to stop, right? So again, pretty much all the benefits of the arena allocation scheme. But now, if you choose, instead of forcing yourself to specify the boundaries at allocation time, you can instead not specify them and have it grow as necessary. And then again, you just have to be aware of the fact that you are rolling the dice now because the operating system may eventually run out of memory, right? Now, that's probably not going to happen these days because there's so much memory running around, but maybe think of a different platform. Think of an iPhone or something where the memory might be tighter. There, you can't just expect to just keep allocating gigabytes of memory and not have any consequences of it, right? So again, don't want to just go hog wild with it, but it's nice to have this other tool in the toolbox. Are we done yet? No. We've got more stuff to do tomorrow, obviously, that we have to do to work on it. So we're going to have some more things to talk about tomorrow. Right now, though, we're over time by 5 minutes, so let's go ahead and go to the Q&A. Anyone who has questions and answers, please go ahead and give them to me now. I think Insobot is starting to be a little bit like a Microsoft Tay. Dear SAD, if you allocate new block after calling begin temporary memory, end temporary memory is going to restore incorrect values, isn't it? Yes. So this is why I said we're not done yet. The begin temp, end temp has to be implemented using a technique that I'll show you tomorrow. It's not particularly difficult to implement. It's just we have one more thing to do. The other thing that we haven't done is for loop live code editing, we need to make those allocations work in a predictable fashion for saving out. So we'll do that as well. So we got at least 2 more things to do. I don't know that we'll get to both of them tomorrow. Begin and end temporary we'll definitely do tomorrow. but depending on how long it takes to debug that, because although it's easy to implement, it's easy to accidentally get a little thing wrong in it sometimes. So assuming that goes smoothly, we'll start on the loop type code editing part, but it may not be. We may have to go into Monday to finish that part. How easy or possible is it to transfer code from Java to an engine that does graphics well? And if it is possible or easy to transfer, which one would you recommend? I'll be honest, I don't really program in Java at all, and I mean, not to be too flippant about it, I don't really care about Java at all, so I haven't ever read up on anything like that. So I have no idea. Absolutely no idea. I would say that, if you're looking for a Java-ish language, meaning something that has a lot of like garbage collection and bytecode things to it, Unity is an engine that's programmed in C#, for example. And C#, if you program in Java, I feel like C# is not a huge, incredible leap to try to make, right? So I would say, if that was your goal, I would probably not do Java. Java just doesn't seem like a particularly good language to use for games nowadays, because I don't feel like a lot of the platforms that you have to choose from have embraced Java at all. Whereas, like I said, C# is like very prominent now in games because of the fact that Unity chose to use it, and so now. You have the option of tying into an engine set there and a whole suite of middleware designed to help you if you go the C# route. If you go the Java route, I can't think of a single professional, the only game I know of even really that ships in Java that anyone ever cared about was Minecraft, and that didn't use a pre-licensed engine. The engine itself is written in Java. And even, and Minecraft isn't a high-end graphics game, right? It's pretty low-end. So, I really just don't know of any kind of, when you say does graphics well, I don't know of any high-end graphics stuff that you can easily tie to Java. They probably exist somewhere, but I don't know. So again, I would say not my area of expertise. I don't do that kind of programming. I only do the kind of low-level gamey sorts of code. So I don't have a particularly strong opinion. All I can say is that if you were, if you're just kind of taking a bird's eye view of it, it looks to me like if I was going to pick one of those higher-level languages, it really wouldn't be Java, because you're not going to get much support there, right? I'd go C#, maybe use Unity, or try Blueprint, right, is Unreal's one. There aren't that many game engines out there, right? There's Lumberyard, there's Unity, there's Unreal, there's GameMaker. GameMaker isn't a does graphics well kind of a thing, though, right? GameMaker is more made for older style graphics, so I don't know that you would include that one. But there aren't that many high-end rendering engines out there to pick from, and none of them use Java as far as I know. Would it be a good idea to store a pointer to the allocator function inside the arena struct instead of using a global? It is if you have a slightly different architecture than we do on Handmade Hero. On Handmade Hero, we do not have different memory pools, so there's only ever going to be probably one allocator, right? But if you are in a heterogeneous environment where you may be getting memory from different sources, then it makes a lot of sense to store the allocator function inside the arena. But on Handmade Hero, it probably wouldn't be necessary, because we probably would never call anything other than the global. Now, if that, again, I try not to do things prematurely, so even if I sort of suspected we might do that, I don't think we will, but even if I suspected we might do that, I probably wouldn't do it now. I would wait until we actually were allocating from multiple pools, just so I could see what the most proper way to integrate that was at that point. But like I said, when you say would it be a good idea, I would say it's definitely a good idea sometimes. I don't think it's a good idea for Handmade Hero, but it's definitely a good idea in a general sense of it is a technique you should consider using if you have the need to have different arenas at runtime allocate from different sources. How do we free old memory blocks if the base pointer always points to the newest allocated block? Again, you're going to have to wait for tomorrow on that. It's exactly the same code as we need for the begin and end temporary blocks, if that makes sense. And so we just have to, we need to do that implementation. And so as soon as we go do that implementation, then you will see. Perhaps I'm missing something, but how do you go back to previously allocated memory blocks, like for freeing memory and saving it out and relocating it? Again, we'll cover all that tomorrow. So don't worry. That will be very clear. It's not difficult. It just requires us to do a little bit more work in that if statement that I was talking about, where we don't care how long it takes. We just need to put a little bit more work in there. And then once we put a little bit more work in there, we will have the information that we need in order to rewind our arenas. Meow. Meow meow. Meow 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 meow. Meow 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 meow. All right. We are just about out of time, and I don't see any more Q colons. So I am going to wind it down. Let's close it up, and close it up. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as it always is. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and I upload the source code every night for your experimenting pleasure. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you want to support our video series, a schedule bot you can use to find out when we are live, and an episode guide maintained by the fabulous Miblo, who keeps it up to date with time-coded markers and everything. So if you want to catch up on old episodes, stuff that we covered in previous episodes of Handmade Hero, that is the place to do it. That is it for today. I will be back tomorrow for the last stream of the week. Tomorrow is a 5 p.m. stream again, so again, keeping with the alternating time slots for people who are in different time zones. Hope to see you all here for that. It's just going to be us finishing up our memory arenas. Like I said, might take us 2 more days, might take us 1. Depends on how quickly we go tomorrow. But basically, you've already seen the idea. Very, very simple. And so now we just have to implement the ability to rewind our allocations, and we will be good to go. That's it for today. Thank you for joining me. I will see you guys on the internet, and then hopefully tomorrow at 5 p.m. Take it easy, everyone.